This video is going to be an introduction to the mole, and the goal for this video is to understand what a mole is and why we use it. Now, the mole is something that tends to be a little confusing for some students, so to help you better understand, I'm going to use an example from our everyday lives. So if you look at the two images on the screen here, you'll see that on the left there is an image of 12 marbles, and on the right there is an image of 12 elephants. Now, in our everyday lives, we have a term that we use to group together 12 objects, and that term is a dozen. So, if we have 1 dozen of something, that means that we have 12 of whatever it is we're talking about, right? So, if we look at the picture of 12 marbles, if there are 12 marbles, I can say that there are 1 dozen marbles. If we have 12 elephants, I can say that there are 1 dozen elephants. Now, for the marbles, if we just pretend that each marble was the exact same size and weight, the approximate mass of a dozen marbles would be around 2 grams. And if we thought the same thing for the elephants, if we pretend that all these elephants were the same size and weight, the approximate mass of a dozen elephants would be 7.5 million grams. So if we look at the masses of these two objects, we can see that they are completely different, right? The mass of a dozen elephants is significantly greater than the mass of a dozen marbles. But the difference in mass in no way affects the fact that we still have a dozen each, right? The thing that affects the fact of us having a dozen is that we have 12 of these objects. If I had 13 marbles, or 14 marbles, or 10 marbles, I would no longer have a dozen. In order for us to have a dozen objects, we need to have 12. The mass of the object plays no effect in that at all. So the same holds true for something in chemistry. So just as 1 dozen equals 12, we have something called the mole. And 1 mole is equal to 6.02 times 10 to the 23rd. So if I said that I have 1 mole of something, what I'm actually saying is that I have 6.02 times 10 to the 23rd of those somethings. Now in this course, those somethings are going to be atoms or molecules. So now to be a little bit more specific, if I said I have 1 mole of carbon, what I'm actually saying is that I have 6.02 times 10 to the 23rd atoms of carbon. One little side note here, this number is called Avogadro's number. Okay, so the fact that 1 dozen equals 12 is the same exact thing as 1 mole equaling 6.02 times 10 to the 23rd. It's the same type of relationship. It's no more complicated than that. Now, let's say I am making chocolate chip cookies. I have a recipe for chocolate chip cookies. And the recipe says that in 1 chocolate chip cookie, there needs to be 1 dozen chocolate chips. Now I know, because of this relationship right here, that the recipe means that there need to be 12 chocolate chips in 1 cookie. So I could very easily go to a bag of chocolate chips and count out 12, right? That's not complicated at all. However, the same is not true for chemical reactions. If a chemical reaction is calling for 1 mole of carbon, because of this relationship, I know that the chemical reaction is calling for 6.02 times 10 to the 23rd atoms of carbon. Now, I can't go into a lab and actually count out 6.02 times 10 to the 23rd carbon atoms. It's just not possible, because think about this number, 6.02 times 10 to the 23rd. What that means is that I take this decimal place here and you move it 23 places to the right. So we're dealing with big numbers here. So if something's asking, if a chemical reaction is calling for 1 mole of carbon, that means I'd have to count out 6.02 times 10 to the 23rd atoms of carbon, and that's just not possible. So we can't count molecules directly, so we need to count moles instead. And in order to count moles, we count moles by using the weight of whatever element we're dealing with in grams. Now, let's go to the periodic table and I can explain a little bit better what I'm talking about. So you should remember from a previous chapter that the numbers underneath the elements here on the periodic table, those numbers are the atomic mass of that element. And if you remember, we dealt with atomic mass by using AMU. Now, we're going to be looking at AMU in a little bit more detail. Now, what AMU is really standing for is AMU is really standing for grams per mole. So if I asked you for the atomic mass of carbon, you should be able to look at this number right here and know that the atomic mass of carbon is 12.01. Now what that's actually saying is that there are 12.01 grams of carbon in 1 mole of carbon. Now notice, just as a little side note, right here for mole, I wrote MOL instead of MOLE. Now MOL is the abbreviation for mole, just as G is the abbreviation for gram. So when you're writing moles, instead of writing MOLE, you write MOL. Okay, so this is really what AMU is standing for. It's saying that there are 12.01 grams of carbon in 1 mole of carbon. Now, this fact is true for every element on the periodic table. If you look at the numbers underneath the elements, their atomic masses, for any element, it's telling you how many grams of that element are in 1 mole. So, for example, if we look at nitrogen, the atomic mass of nitrogen is 14.01. Therefore, there are 14.01 grams of nitrogen in 1 mole of nitrogen. If we look at oxygen, rounded to 2 decimal places, the atomic mass of oxygen is 16.00. That means that there are 16.00 grams of oxygen in 1 mole of oxygen. Okay? So let's tie this all together now. So if we're looking at, let's say we have carbon and we have nitrogen. If I have 1 mole of carbon, that means that I have 6.02 times 10 to the 23rd atoms of carbon, right? Because 1 mole of something equals 6.02 times 10 to the 23rd of that something. In this case, we're talking about carbon. Now, if I asked you how many grams of carbon are in 1 mole, you get that number by looking at the atomic mass of carbon. So the atomic mass of carbon is 12.01. That means there are 12.01 grams of carbon in 1 mole of carbon. Likewise, if you look at nitrogen, and we have 1 mole of nitrogen, that means that we have 6.02 times 10 to the 23rd atoms of nitrogen. Now, if I asked you how many grams are in 1 mole of nitrogen, you look at the periodic table and you look at what the atomic mass of nitrogen is, and you will see that the atomic mass of nitrogen is 14.01 grams. That means that in 1 mole of nitrogen, there are 14.01 grams of nitrogen. So I can't go into a lab and count out 6.02 times 10 to the 23rd atoms of nitrogen, but I can weigh out 14.01 grams of nitrogen. So if I weigh out 14.01 grams of nitrogen, I know that I therefore have 1 mole of nitrogen, and I therefore have 6.02 times 10 to the 23rd atoms of nitrogen. So all 3 of these numbers, moles, atoms, and grams, are related to one another. There's a relationship between all 3. In a future video, we are going to look at how to convert between all three of these numbers. So if I tell you I have a certain amount of moles of an element, you need to be able to tell me how many atoms of that element I have and what is the mass of that many moles. And likewise, if I tell you I had, say, 20 grams of nitrogen, how many moles of nitrogen is that? How many atoms of nitrogen is in that many moles? So we'll go over those skills in a future video. But this video was just an introduction to the mole. It might be something you have to watch a couple times to fully grasp what the mole is, but you also might get a better hang of it as we start going through some of the calculation questions regarding the mole. So hopefully that made a little sense to you and didn't totally confuse you. But if it did, please feel free to send me a message and ask any questions, and I can try to explain it a little bit better.